Hi, my name is Eva, and this is my lab report for the first lab of 6-2 on charged tapes. So the goal of this lab is to use tape to see the transfer of electrons between surfaces and calculate an estimate of the charge or the number of electrons that are transferred. So there's a couple of physics principles that were used for this lab. First, I used Coulomb's law, which I put the formula for right there, which to use this formula, I assumed that each of the pieces of tape has an equally distributed charge over the full piece of tape. Um, then I also used Newton's second law, which I used with Coulomb's law to find the charge on each of the tape pieces. And I also used some atomic dimensions to find the number of excess electrons per atom on the piece of charged tape. So what happened in this lab is that so I first saw that the tape has a mass of 0.231 grams, and this caused a downward gravitational force of 0.00226 newtons, and I show my calculations later in the lab. The surface area is 0.0052 meters squared, with about 5.2 times 10 to the 14 atoms on the sticky side, and it holds about 7.5 times 10 to the 10th excess electrons. So this means it has a net charge of about negative 1.2 times 10 to the negative eighth coulombs. And only about 1 in 6.9 million atoms carried an excess electron. So it's a very small spread out negative charge. So to model um, this, I had to make some assumptions to explore the interactions between the point charges on a larger scale. And I used um, pieces, individual pieces of charge tape as a physical representation of the point charges. So I had to assume that air resistance is negligible and that each piece of tape is modeled as a point charge located at the center. And each U tape started with an equal amount of charge that is uniformly distributed along its length. So for the experiment, I used two pieces of Scotch tape that were the same size and then one neutral tape just adhered to the desk. And you can see kind of in the diagram, but tape B was pressed along the desk and then quickly pulled off, and this charged it by having it gain or lose electrons, and then it was suspended near various objects to determine if it had a positive or negative charge. And tape A was charged using the same method, and then I positioned tape B above tape A until it began to float, which means that there was electrostatic propulsion, and the vertical distance between the tapes was measured and then used to calculate the charge on the tape. And then here I showed the formulas that I used, and I took dimensions of all the tape. And it looks like some of my formatting got messed up, but you can see the measurements we did. Um, yeah, and the formulas I used to find the surface area of the tape and the atoms in the tape, the electrons per atom, the gravitational force, the electric force, and then T1. And I used like that, but you can still see the measurements. So basically based off of my experiment, I saw that the tapes repelled each other and the tape was attracted to my hand and to a pen, and the suspended tape and another tape repel each other. So this means that the tape became electrically charged during separation, and like charges on them cause them to repel, and the attraction to my hand and the pen suggests they were either neutral or oppositely charged. And electrostatic forces between the tape show that the model of treating them as point charges with net charge. Then I also used GlowScript here to kind of model what was happening virtually, where I took the dimensions of the tape and then used these formulas again in this code to model what was happening and got measurements, which you can see in the bottom left. So basically, there are some sources of error. So the mass per length approximated might not actually be accurate, and I've simplified a lot of the measurements. And I also assumed that the charge was concentrated at the center of each tape strip, but this might actually not be the case, and they might have different charges. But something interesting to think about would be if the distance between the tapes were changed and how this would affect um, the charge that I calculated in the simulation. And why do we assume that the tape has uniform charge, and how would a non-uniform charge affect the results? And that's all.